This is Gutianai. This is my demonstration for assignment 4 MIP mapping. In this sense, I have implemented a completely procedural environment to visualize how texture filtering works. I have three main objects: checkerboard floor, a brick crate on the left, and a unique rainbow sphere on the right to visualize MIP mapping levels. First, let's look at the problem. I switch the filtering mode to the nearest neighborhood with the MIP mapping disabled. If we look at the floor, especially in the distance, we see several small patterns. The high-frequency checkerboard creates noise, vectoring artifacture because we are undersampling the texture. Now, look at the brick craft on the left. I procedurally generated this texture with extremely thin, 1 pixel wide, more materialize because we are using nearest sampling. This thin line break and flicker as object rotators. This is a classical example of spatial aliasing. The simpler misses the white line entirely in some frames. On the right, we have the sphere. Notice it looks like noise, black and white statics. This is because the GPU is forced to simple level 0 of the texture, which contains a high frequency grid pattern. Since MIP mapping is disabled, we don't see any color yet. And I switch the linear. Yeah, uh, it's the same behavior, but it's a little bit better. Now let's turn on the MIP mapping. I'm switching to nearest MIP mapping nearest mode. Look at the sphere now. This is a unique feature of my model, the demo. I manually colored each MIP level. Level 1 is red, level 2 is green, level 3 is blue. You can clearly see the hard edge between the color. And this visualized GPU's decision make process based on distance and angle. It jumps discretely from one texture resolution to the next. Also notice the flow. The noise pattern in the distance are gone. Instead, the flow turns solid gray. This is correct behavior. As the texture resolution drops, the black and white pixels blend into a average gray, eliminating the aliasing noise. Finally, let's switch the model to trilinear filtering, linear map linear. On the sphere, the hard edge between the rainbow ring are gone. The GPU is now linearly interpolation between the red level and the green level, creating a smooth grid. On the brick crate, the thin white lines are no longer broken. They are slightly blurry, but they are continuous and stable, which is much more pleasing to the eye. Using the MGI panel, I can adjust the UV scale in the real time. Increase the floor tying makes the texture denser. Yeah. Notice how the gray zone move close to the camera. This is because the texture frequency is increased, forcing the MIP mapping system to switch to lower resolution level earlier. Similarly, increase the sphere UV distance. Compress the texture coordinators. You can see the rainbow rings stringing towards the center. The confirm that MIP mapping selector is driven by the ratio of the texture pixel to screen pixel. In summary, this model demonstrates how MIP mapping solve aliasing artifacts by prefactoring textures, and how trilinear filtering provides the smoothest visual result. Thank you for watching.